Good morning, my dear children. So today we are going to study the characteristic of center of mass and how to locate the position of center of mass in different bodies. Here on the screen, I am showing some pictures and videos. You see here. When she is raising her hands, here she is bringing her two hands towards her body. When she is bringing her two hands towards her body, her center of mass is located at her navel. When she is raising her hands up, the center of mass of her is also shifted towards up. So, what do you understand? If the distribution of mass of the body is changed inside the body, then the position of center of mass is also changes. So, center of mass is always shifted towards heavier mass. Where the mass is more, toward the side, center of mass will be shifted. So, you studied in the case of Earth and Moon system. The mass of the Moon is more than that of the mass of the Earth is more than that of Moon. That is why the center of mass lies inside the Earth. So, center of mass is shifted towards heavier mass. So, in high jump, here one player, she is participating in high jump. So, here also our center of mass is also moving in a parabolic path. Here the motion of center of mass of in high jump, here we are seeing like this. Here the position of center of mass in high jump, when they are at the same height above the pole, the center of mass is outside of their body. Their center of mass will be located located here outside. So center of mass lies inside the body or within the boundaries of the body. At the center of mass no need to present. Next. So the position of center of mass depends on the shape and size of the body and the distribution of its mass. Hence, it may lie within or outside material of the body. And based on these characteristics, there are some questions are framed in the textbook. For very short answer questions, for examination point of view, you may encounter in 2 marks. So here I am saying one question. You see, so what is the difference in the position of girl carrying a bag in one of her hands and another girl carrying a bag in each of her two hands? There are two girls. You see here in this video. Here one girl carrying a bag in one of her hand. Here another girl carrying two bags in her two hands. In both cases, how their center of mass will be located? What is the difference in the position of center of mass of these two girls? A girl, she has one bag in her hand. Another girl has two bags in her two hands. Now, what happened here in the first case? A girl who has one bag in her hand, her center of mass is shifted towards that hand. In which hand bag is there? A girl carries, you see, a bag with one of her hands. The center of mass of the girl is shifted toward that hand, and that girl is bent toward the back side because of greater mass. Now here in this case, the mass is more at one side. That is where a center of mass is shifted toward that hand, in which hand bag is there. But here, in our two hands, two bags are there. Here our center of mass does not changes. Why? Because in two hands, two bags, mass is uniformly distributed in our body. That is why in this case, our center of mass does not changes. If another is carrying a bag in each of our two hands, in this case, the position of center of mass does not change because of symmetric mass. Symmetric mass means mass is uniformly distributed. You see that? Now here another question. Is it necessary? Is it necessary that a mass should be present at the center of mass of any system? No, it is not necessary to have any mass at the center of mass. In some cases, center of mass of the body may be lies within the boundaries of the body. So when the center of mass is within the boundaries, at that point, no mass is present. Here is one example. The center of mass of halosphere and the circular ring is at its center. Then there is no mass is present. Where there is no mass particle. So you see in this figure, this is halosphere. In this halosphere, the center of mass of the halosphere is at its center. Here no mass is present. Now you see center of mass in back jump. In back jump, what happened? There is no external torque on him. He is doing some feats with his bike. But what feat he is applying only is muscle force, which are nothing but internal forces. Those forces does not change the position of center of mass of the system. Here in the case of back jump, here is one parabolic path. The center of mass of the bike and the person, it reaches the ground in a parabolic path. So by this example, what do you understand? The position of center of mass does not change with the effect of internal forces. Only external forces can change the position of center of mass. Here another example. If a bomb thrown into air explodes in the mid-air, the center of mass exploded pieces follow the same parabolic path as that of unexploded bomb would have followed, since the forces of explosion are internal forces. Here in the air, in the middle air, the bomb is exploded. When the bomb is exploded, what happened? The all fragments of the bomb are moving in different direction. But one particle of the bomb, the center of mass of the particle, the center of mass of the bomb should reach the ground same as is in parabolic path. Before explosion, how would the bomb is moving? After explosion also, its center of mass would move in the same path and reaches the ground. Why? Because here the explosion of bomb only because of internal forces. There is no any external torque, external force acting on the bomb. So what do you understand by this example? Internal forces cannot change the position and the motion of center of mass. Only external force can change the position and the motion of center of mass. Now you see the bomb is exploding. Then you watch this video to show the motion of center of mass when the bomb is exploded. You take here watermelon. So you imagine this is a bomb, watermelon. When it is exploded, what happened? No external force on that watermelon. So this is splitting into different fragments, which all are moving in different direction. But the center of that watermelon would move in the parabolic path. Again, here internal forces do not affect the motion of center of mass. If no external force acts, the center of mass may be at rest or move with constant velocity. Another interesting question on internal forces. Now you see here, there is a train compartment. So in the train compartment, there are some passengers. Due to difference of opinion among them, some physical fight starts. You see here, I think it is metro train. So when a physical fight starts among the passengers inside the compartment, so this physical fight can change the position of center of mass of the compartment. That is the question. You see here, there are 100 passengers in a stationary railway compartment. A physical fight starts between the passengers over some difference of opinion. Here there are two questions. Will the position of the center of mass of compartment change? So first you think, when physical fight starts between the passengers, the physical fight can change the position of center of mass of the compartment. Yes, the answer is yes. The position of the center of mass of the compartment will be changed because the passengers are external force for the compartment. No, you don't listen. The position of center of mass of the compartment will be changed because of the passengers are external force for the compartment. Now there's another question. Will the position of the center of mass of the system, not compartment. Now I'm talking about the system. System means compartment plus 100 passengers. Will the position of center of mass of the system change? No. If you talk about the system, the position of center of mass of the system cannot change. Why? Because the physical fight, now it is internal forces. The position of center of mass of the system will not change as there is no external force. If you talk about system, compartment and passengers together, if you take for that system, physical fight is internal forces. That is why the center of mass of the system cannot change. If you take only compartment, for compartment, the passengers are external force. That is why the position of center of mass of the compartment will be changed. Now I am talking about how to locate the center of mass. And already here Earth Moon system. For a two particle system, first we talk about two particles. The distance of particles from the center of mass are in the inverse ratio of their masses. If you take only two particles, so here in the picture shown, here one particle mass m1, the other particle mass m2, their masses are not equal. The m2 is more than that of m1. Now what happened? The center of mass is nearer to the heavier mass. Their masses are m1, m2. Now you take the distance d1. Now this is the distance from, this is d1. No, no, from the center of mass, the smaller mass of the body distance is given. The heavier mass of the body distance. Now we take heavier mass. So its distance is to take d2. So what do you understand? If m1 is less, d1 is more. m2 is more, d2 is less. So what do you understand? For two particle system, for a two particle system, the distance of particles from the center of mass are inverse ratio of their masses. The smaller mass is always far away from the center of mass. Heavier mass is very closer to the center of mass. Already you people proved in the case of Earth and Moon system. To take for symmetrical bodies, in which the distribution of mass is homogeneous. Homogeneous means the body in which the mass is uniformly distributed. The center of mass is considered with the geometric center. Here some shapes are given. Here you take a rectangular shape. So what is rectangular? The opposite sides are equal. So in the rectangle, if the shape of the body is rectangular shape, the mass is uniformly distributed. Then its center of mass is located exactly at its geometric center. So this is the center of mass. So this is the center of mass of the body, geometric center. Here, the center of mass. If you take a triangle, say the mass is uniformly distributed, then its center of mass, the center of mass of that rigid body is coincident with geometric center. Suppose if the mass is not uniformly distributed, then we choose the position of center of mass by taking a suitable coordinate system. By taking a suitable coordinate system. So how can we take the coordinate system to locate the position of center of mass in different cases? No, no, yes, center of mass of two particle system. We are choosing like this. So this is coordinate system, horizontal axis, vertical axis, two masses m1, m2, like this, x1, x2, their horizontal distance, vertical distance. These are the vertical distance. Like this. And if you take a line parallel to the surface of the earth, this is called x-axis. If you take another line perpendicular to it, this is y-axis. So this is coordinate system. Suppose if you want to choose two particles, the mass is distributed uniformly, only one direction. Then what happened? The body has only one coordinate like this. Then here I am taking two bodies of their masses m1 and here another body of mass m2. So to locate the position of center of mass of these two particles, their center of mass may be lies. If the two masses are equal, then exactly their center of mass will be takes place at exactly midpoint. So to know the position of center of mass of these two particles, we should take only one coordinate, that is called x coordinate. Its distance is x1. Now you take this one. X2. Now, if you want to look at the center of mass, it has only one coordinate because the two particles are distributed only one axis. So m1 x1 plus m2 x2 m1 x1 plus m2 x2 by m1 plus m2. Suppose if the two particles are located in two different directions, then we have two coordinates like this. Suppose if one particle is here, another particle is here like this. Now we have two coordinates. Now their center of mass may lies here. To know the position of center of mass, we want two coordinates. This is horizontal distance x coordinate, vertical distance y coordinate. So if the mass is distributed in three directions, in three dimensionally, then we need three coordinates. So like this. So if particles are distributed linearly, then center of mass has single coordinate only. If particles are two-dimensionally, then center of mass has two coordinates. If the particles are distributed three-dimensionally, then it has three coordinates. X coordinate of center of mass, Y coordinates of center of mass, Z coordinates of center of mass. Thank you. In the next class, we will discuss some problems.